Hi, I'm Pat Kelly. Okay, in this problem, the situation is that they tell us we have a normal distribution. It has a mean of x bar and a standard deviation of sigma. And you have to be told that information up front. And then they want us to imagine if you were to select an x value at random from that distribution, what's the probability that that value of x that you select would be less than or equal to x bar minus sigma. Okay? Might sound a little involved, but let's make sense of it. Now, I'm telling you that they have to tell you that it's a normal distribution, the mean is a certain value, and the standard deviation is a certain value, because that's what allows you to set up what I've already drawn over here is our good old bell curve, the normal distribution. And what we will always know with our normal distribution is that the x bar is right in the middle, and then the significance, or one of the significances of that standard deviation, is that if you start taking steps away from that middle, where your steps are the size of a standard deviation, then you actually know what percent of the data falls within each one of these regions. Okay? So we're going to take one step to the left of the middle, and that's going to be my x bar minus sigma, right there. And that's relevant in this problem because that's what they're asking us is what's the probability that x is less than or equal to that. So then what I'd like to do is make sure you get a good visual of this probability that they're asking for. So in other words, what am I looking for visually on this graph of mine, this normal curve? And that really comes down to, in this case, the less than or equal to my x bar minus sigma. Less than or equal to is just to the left. And it's actually forever to the left. So I'm shading all of this forever to the left of the bell curve. So what we've translated is this probability that they want from us is actually that area, my green area. And I mentioned how you should know, you hopefully do know, these different percentages of the regions that we've broken up our bell curve into. So let me grab something to label these. You end up memorizing these, but you do want to know, like this slice here is 13.5%. This slice here is 2.35%. And you can see with my green shaded part of the curve, the one I'm interested in, I also need this last little slice. So this curve here, see if I can get down, that's a measly little 0.15%. Okay? And for this problem, those are the only regions I need, those three slices. You do want to make sure you know all of these other regions. There's not too much more to know. This one slice here, the first one that's not shaded for me, that's 34%. Maybe that'll sound familiar to you. And I'm only throwing that at you because if you know that one and these three that we are working with, you know the whole curve, because the other side of the bell curve is just a mirror image. All right, I'll leave that for you for another problem. For us, for this problem, all we have to do now then to find this answer for probability is add our green shaded region, which are these three different percentages. So I need 0.15% plus the 2.35% plus the 13.5%. Okay, calculator if you want, but what are we looking at? 16%. All right, I'm happy with that, but sometimes you want to see a probability as a decimal, especially when you look in the back of the book to see if you match the answer. You might see this as 0.16, but you know those are the same number anyway, right? Okay, that's what you need to know. It really does come down to knowing those different slices of the bell curve. So practice, practice, practice. Okay?